So we're going to start with Ruben's going to talk about pollution monitoring, and then we'll go from there. Milos is going to talk to us probably around 8 o'clock about blood pressure monitoring. And yeah, welcome to February. Go ahead, Ruben.
Okay. Hi, so my name's Ruben, and about last autumn I got involved with this project to do with pollution monitoring along the River Brent. Sort of by accident. I belong to a litter picking group that so once a month we go and litter pick along the Welsh Harp. It's also known as the Brent Reservoir. And through that, I met a group of people who were involved in pollution monitoring of the River Brent. And they already developed some equipment through sort of maker projects to using the Raspberry Pico to detect pollution in the River Brent. But they needed more help with electronics and software. And so I got involved. Through that. And so I'm going to talk about how this equipment works. But before we do that, let's just talk about some of the pollution that we're concerned about. There's quite a lot of pollution in the River Brent. Some of it comes from industrial premises. Other is sort of from housing estates, domestic washing machines, raw sewage. A lot of it is from misconnected pipes. So back in the 60s and 70s, when sewage pipes were being reconnected to main sewers that they were building, a lot of them didn't get connected properly. As a result, there's a lot of sewage gets dumped into the river, which is a bit unfortunate because the River Brent also flows into the Thames. And the other thing we get a lot of is road runoff. So a lot of the Brent runs along some pretty major roadways like the North Circular, for example. The type of parameters that you're testing for with river pollution, one of them is the TDS, the total dissolved solids. That's usually measured in parts per million. The other one is temperature. If the temperature suddenly goes up because a load of pollution is steaming up somewhere. Then we've got dissolved oxygen and the pH, which is the acidity. And the other thing you can be looking for is ammonia or ammonia nitrates. A professional pollution detector, or a sonde as it's called, which can detect multiple parameters, they cost over £10,000 per installation. So that's very expensive. The environmental agency, they approached the volunteer group that's involved with designing these pollution detectors. It's a group called CURB, standing for Clean Up the River Brent. And they're sort of currently hampered. Their budget constraints, it means that they're a bit hampered in buying these expensive £10,000 sondes. So they're actually funding the development of these low-cost pollution detectors that have been developed with the Raspberry Pi chip. Well, the Raspberry Pi, the RP2040 chip. And if these devices are successful, what will then happen is they're going to be spread around to other groups around the country monitoring the rivers. And then the environmental agency can start building up a sort of picture of pollution across the country. That's the long-term plan. Now, what we're doing to measure pollution is basically just using two of those parameters. We're going to measure a total dissolved solid and temperature. The sensors or the probes for those, that they're relatively cheap, which is why we're doing it that way. Now, with regards to total dissolved solids, the way water is classified with that parameter, fresh water, you'd be looking at a TDS value of sort of under 1,000 ppm. Brackish water is about 1,000 to 10,000 ppm. Saline water is about 10,000 to 35,000. Drinking water that you might drink at home is typically below sort of 500 parts per million of total dissolved solids. And swimming water tends to be considered safe if the TDS value is under 2000. Now, it's quite difficult to always say that big TDS values are always going to be pollution. You don't really know that. There could be other factors. So what we tend to look for with these detectors is if there's a sudden increase in the value of TDS. So, for example, if there's an increase in sort of 20% in under 24 hours, there's probably been some sort of event, maybe a sewage outflow or something like that into the river. Well, so what TDS, the way that's measured, you do it by measuring the electrical conductivity of the water. And so that conductivity, that's affected by, like we mentioned before, sewage, which is food waste. In the terms of the River Brent, what we've discovered, there's actually quite a lot of poo in there. And when we measure the TDS value, you can see a spike in the morning and in the evenings. What's happening is, people are getting up in the mornings, then they go to work, and the TDS value settles down again, and it spikes again in the evenings when people come home from work. The other thing is ammonium nitrates that we see a lot of, and road runoff. So typically things like grit. So if there's been a heavy rainfall, a lot of that water that's on the road washes into the river. What you can't detect with the TDS probe is oil, is the presence of oil. Temperature, when we're looking at measuring temperature, so you need two detectors for that, one upstream and one downstream. If there's a relatively small increase of something like, say, 3 degrees C, that's not too worrying. But if you get a sudden increase of 10 degrees C between the two sensing points, then that would be concerning. And that might be, there's something has just been dumped into the river, basically. So a gentleman called John Clifford, who belongs to Curb, he's a Curb campaigner. He originally came up with the original design of the of this monitoring equipment based on the RP2040, and he did it by cobbling together a number of sort of major components, which was the Raspberry Pi, the 2040 chip, which is used in the Pico. There's a very popular SIM modem or mobile modem called the SIM 800, which is basically a sort of GSM and GPRS modem. It also does text messaging. So we use that to transmit the data to a web server from each of these monitors. And we're using on the circuits as well, we've got a battery charger. Then under the board, we have a battery pack. The battery is recharged with a solar panel. And then also we've got the temperature and the TDS probes. In the previous picture, you can sort of see the solar panel at the top there of the post. There it is there. And there's the box with all the gubbins in it, with the Raspberry Pico type device. And then you've got the probes dangling on wires going into the water. So this was one of the first boxes. And I think you all know what the RP2040 chip is like. One of the main reasons for using that was it's very cheap, it's only 50p. The other very useful thing on this device is the 4 analog to digital converter channels. Plus this device also has low power states, which is going to be very useful. The SIM 800 modem, this is very popular for IoT projects. It's pretty low cost as well. And so we use it for GPRS messaging. So sending the data. We send the data to a web server from each of these units approximately every 15 minutes. The solar panel design, again, this was based on an Adafruit system. So you can go on their website and you'll see how they've used a TI chip, the BQ24074 battery charging and management device to take current from the solar panel and use that to charge up a battery. So we basically have integrated the same circuit onto the board that we're using. The original Brent box, as it's called, in recognition of the River Brent, all the components were pretty much sort of breadboarded. So when you look in that box there, you've got there's a separate circuit board for the charging, for the board that contains the battery management circuit that's used in the Adafruit design. We've got the Pico board down there on the right. There's the TDS probes comes with a little circuit board as well, which converts the voltage from the TDS probe into a voltage that the ADCs on the Raspberry Pi Pico can use. And so all these little boards, they're interconnected through a breadboard in the middle. And underneath all that is the battery, is the battery pack. So from there, it was decided to develop a PCB to integrate most of that onto a printed circuit board, like that. So this is obviously a lot neater. So along the bottom, there's these JST connectors, and they're used for connecting the sensor probe cables. They're reasonably reliable. They've been pretty robust in the field. They're a bit of a pain to use because the cables that come with the probes, we have to fit the JST connectors on there manually. So we do a lot of crimping. You need to have some pretty steady hands for that. Currently, the PCB, it's a 2-layer board, which is manufactured by JLC PCB. So this is really sort of where I joined the project. Once they developed these PCBs, there were some bugs on this. There's some noise issues. So initially, I was helping just crimp the cables and the connectors for these things. But then I got involved as well in debugging the noise issue. What was happening was some boards were working and some weren't. Basically, by working and not working, what I mean is the ones that weren't working basically weren't registering with the mobile phone network, and then basically just crashing every time they tried to register with the network. The board would just crash. What appeared to be happening was this big SIM module up here. That's when I talk. The SIM 800 module. Unfortunately, SIM also uses the same word as SIM card, but this SIM 800 module here, that's effectively the mobile phone device. When that's trying to transmit on certain bands, it may even attempt to sort of transmit using about 2 amps of current. So you get a 2 amp current burst, and we suspect what's happening is with that big burst of current, it was causing a lot of ground bounce and noise and causing the Raspberry Pi chip to crash. We noticed that was generally happening when the way this module works, it can work on multiple bands, and the SIM card that we use from a provider called Things Mobile, they're basically IoT SIM cards, I mean, and they enable you to jump on multiple service providers. So wherever the signal is the strongest, or whichever service provider is providing the strongest signal, it'll jump on that. One of the things we realized was when it was trying to jump on a 900 megahertz band, this is when when the board would crash basically. If the board tried to jump on an 1800 megahertz band, it was fine. Now, on the 900 megahertz band, you can actually transmit power levels up to about 2 amps. On the 1800 megahertz band, you're restricted up to sort of 1 amp power transmission. So that's where that's probably where we thought what's going on here is that because we've got these 2 amp current bursts on 900 megahertz band. That's probably what was causing the crash, the noise and ground bounce issues. Because this is only a 2-layer board, so we don't really have a solid ground plane. So what we did as a workaround was in code, we basically prevented the mobile phone chip here from using 900 megahertz bands. So that's a fix anyway. So in the next revision of this board, we'll have to, what we're going to do is go to a 4-layer board and see if we can get around these ground bounce issues. It took a while to debug that though, but luckily we had working boards and non-working boards, and then we were able to compare boards on different bands. The probes we're using, so the TDS sensor, it's the one on the left there, it comes with a little circuit board, and that's basically just a voltage conversion board. It converts the voltage from that's output from the TDS probe into a voltage that's within the range of the analog to digital converters on the Raspberry Pi. And then these are sort of standard. That should really be, oh yeah, and then the temperature sensors here. You can get those for about £3. Pretty much everything, the way these are built, have been ordered from parts of Amazon, really. So with those PCBs, I've got a live one here which is working at the moment. They get put into these junction boxes. All these junction boxes are sitting on solar panels here at the moment, ready to be deployed. Oops. And this is all assembled by hand, really. We've got a team of, there's a little build team that we have based in Ealing. And they help put this stuff together. So the only thing that's really mass produced is the actual PCBs themselves. They get delivered. And then everything else has to be assembled by hand, really. So the whole unit, so solar panel plus junction box, but everything plus everything that inside there is basically less than £200. So this is one of the reasons why the Environmental Agency is very keen on using these. So yeah, it's a lot cheaper than £10,000 for a professional one. The software design. So for the mobile phone module, the SIM 800 module, there's actually a MicroPython library for that, so we can use that. And what we've also programmed in there is a sleep interval. So when the battery power decreases over time, because we can't, the amount that the battery gets charged up by is going to be depending on the sunlight, really. Over time, the amount of charge that's sort of being used up by the battery can't be fully replenished by what we're getting from the solar panels. So the battery capacity sort of steadily decreases. So we're detecting that within the software. As that happens, we then increase the sleep interval between transmissions. So we have a nominal sleep interval of 15 minutes, but as the battery capacity lowers, we start increasing that interval to maybe once an hour, then maybe longer. So the way the sort of software that we've got running, we've got MicroPython code on the RP2040 chip. That's using the IoT protocol MQTT to transmit these parameters: temperature, the TDS value, what the voltage is on the battery, and also the battery capacity, to a platform called thingspeak.com. It's a popular IoT platform. What you do, you sign up to get some channels where you can store your data, and each channel you get given what's called an API key for that. And that API key, you embed that into your HTTP request. And then when you're sending data, you're basically using a key to access one of your channels in thingspeak.com, where you can then store your data. So that's a very useful service. From that, we have a dashboard using an app called Shiny, which you might have come across. So Shiny is it used to be mainly based on the programming language R for statistical analysis. It's very useful for plotting graphs, but it also allows you to plot graphs and lots of other information straight to the web. So it's a whole package of graph plotting plus web display. So you don't need to know any HTML or anything like that. And that will take data from a ThingSpeak channel and basically plot it. So it's very quick to make dashboards with the Shiny app. Since 2022, it's also been using Python. So you've got a choice of coding that up in R or Python. The SIM cards we use, they're from Things Mobile. We get a whole bunch of them, and then we pay about £60 a quarter for them. All that's being done on them is basically sending data. So these devices, the way they get deployed, there's a number of different ways. So the build team is coming up with different ways of deploying these in the river. So one of the ways, for example, is to use a raft. Here's an example of a raft. And so that would be, for example, parts of the River Brent tends to flood quite quickly. The level goes up and down very quickly. So putting things on a post there doesn't make much sense. So we've got a thing called the post topper. So these are these boxes here. Got the solar panel on top, and they would be mounted to a post. Here on the left, you can see one actually at the outflow of a pipe here going into the River Brent. And then you've got the wires dangling down, which are the probes. And we've got floating devices. See the box there and the solar panel on top. Whoops. So they're coming up with different ways of deploying these. There's a thing called Pipecraft as well that's been developed. So that doesn't have a solar panel, but you can easily put that next to an outfall. Maybe leave it there for a week or so. There'll be enough battery power in there to keep it going. So they're gradually being deployed along the River Brent. We've also got one up at on the Welsh Harp near Staples Corner. One of the issues we're facing is vandalism. So we've had a number which have just been wrecked, basically, unfortunately. So the build team is trying to come up with different ways to make these devices sort of less visible, and also positioned in such a way that they're not, makes it harder for them to be got at. We've got a guy who's about 6'6", and he's got waders that go more or less up to his chest, and he's very good at deploying these devices and wading in. And here's an example of a graph here. So this is I think I did this this was from last Sunday. This is one of the boxes deployed near Staples Corner, and the blue line is the TDS value. You can see during the day, oops, the TDS was pretty high. So there's probably a lot of road runoff there. And then at night in the morning, it suddenly drops. And then later the next day, it starts creeping up again. So maybe that's traffic related, we don't know. The orange line, that's temperature. And again, in the night, you see the temperature dropping, and then when morning comes, it starts creeping up again. This is one of my units, which I was experimenting with. Got the two probes in there, the temperature and the TDS. I've got one, so for people who are here in real life, they can come and see one working here afterwards. It's on the. I've got a cup. I've got a beaker here with lots of salt in it, so you can measure some TDS. And future plans. So there's going to be lots of data coming from these units. So one of the things that one part of the team are working on is developing a statistical sort of model that can correlate the temperature data and the TDS data with pollution events. So quite a lot of checking has to be done. When you see a sudden increase in TDS, what type of pollution might that be? So, yeah. The other thing, what we're doing is trying to increase the build rate of these devices and try and get more and more of these deployed. There's a lot of locations where you want something upstream and downstream. You can't just have something downstream or something upstream. You actually need the two so that you can get a comparison in measurements. So that's gradually happening. This is all being done by volunteers, so it has to be done in people's spare time. We've got a couple of other river groups interested in it as well at the moment. There's a group with the River Crane. They've been to a workshop to learn how to do to sort of partially build these units as well. And also there's a group in Cambridge who want to deploy these in the River Cam. We haven't open sourced the design yet. We're looking at to do that with the respin of the board. We just need to iron out a few more sort of bugs on this board so that there's a much more robust design. And then we'll open source the hardware design and the software design. Thank you. Any questions?
Questions in the chat. See the chat on here.
Oh, right. Oops.
Yeah. Yeah, so questions about the SIM 800, whether it's using only 2G or whether it uses 4G or.
It's not future-proof for 5G, no. It's quite an old module. So it's mainly 4G.
The name of the IoT TSM service?
It's called ThingSpeak.
ThingSpeak.
Yeah, thingspeak.com. There is a SIM 7600 module. That's pretty much future-proofed. I mean, we're not expecting GPRS to go out of. I think the nice thing about the 800 is that you can transmit data on GPRS. So we're not expecting that to sort of go out of fashion for a long time. And it's relatively the power consumption of this module isn't too bad. There is a Meteor one, which is the 7600. But
Sounds like the data is quite cheap as well.
Yeah.
Yeah. Someone's
So-
asking in the chat whether or not it work on a hot tub with TDS monitor.
Sorry?
Someone's asking whether TDS monitor work on a hot tub.
Oh, we haven't tested that. Okay. You could try it. Yeah, we did. Yeah, LoRaWAN was initially considered, and they did actually make a LoRaWAN version, but you need base stations for that. So the deployment got a bit too complicated for that. So this seemed like the easier way. I mean, at some point, they also want to go towards looking at a mobile phone device where you can, we can have GPS data, so that it makes it easier to locate these boxes. So that's, but yeah, LoRaWAN was definitely considered, and like I say, a basic unit was made with that, but you would then need base stations in the field, and that gets tricky. Deploying anything in the field is actually getting it's quite awkward here in this sort of environment.
Any scope for water power rather than solar power?
Well,
Turbines or water wheels or-
yeah, I know. I mean, sort of people have been scratching their heads about that. Yeah, I know.
Yeah.
Some sort of wave power. Yeah. I know. It's I haven't really come up with a solution for that yet. Yeah. To be honest, the biggest problem with especially somewhere like the River Brent, which is quite narrow for a lot of its path, is vandalism. We had one guy destroyed about 3 of our units because he seemed to think that it was some sort of equipment for monitoring beavers, and he was worried that we were introducing beavers to the river, and so it's been quite tricky actually.
Just on that sort of lifetime of the GSM network,
Yeah.
because I can see that they just had a quick check.
Yeah.
Because I did wonder about that.
Yes.
I've seen a number of things saying they are beginning to phase it out.
That's right. Yeah.
So, what's the expected lifetime of these units on the current design? Like how long do you expect them to be deployed for before you replace them?
If we get about a year out of them, that's pretty good. But then what do you mean, replace with a new design, or just replace them generally with the existing designs?
If you're designing a product that you expect to last a year, then it makes perfect sense that you wouldn't bother with anything more at the moment than GSM. But if you were saying we want to get a 10-year life out of them, then that's a very different scenario.
Well, we're expecting GPRS to last a few more years. We're transmitting over GPRS.
There's a lot of stuff being switched off, but it will be around.
Yeah.
I think it must go by 2033. I think that was the deadline.
Really, for all GPRS, because I mean, it's going to be a lot of IoT equipment based on GPRS.
I read they have to be shut down.
Oh, okay, that's interesting. 2033. Well, that gives us enough time to.
Yeah. Which is kind of where I was going.
Yeah. No, I mean, we were sort of assuming with GPRS that'll be around a few more years. GSM might.
Well, GSM is the same thing.
Yeah.
It's all
Well, the original
2.5G.
2.5. Yeah.
They're all based on the same
Yeah.
sort of TVMA
Yeah.
systems.
Yeah. Yeah.
And your little kind of issue with the thing crashing,
Yes.
is, was it definitely grounding rather than just too much power being drawn and basically maybe more sort of capacitors at the right type in the right places may solve the problem?
Well, to be honest, the board layout is not that great on here. What happened was that it was contracted out to a chap in India, and who did this is sort of before I got on board anyway. So the specific the whole we have a everything was sort of breadboarded in England first, to make sure everything could sort of work, and then the specification was drawn up based on that, and then using 5R, you've got these contractors you can use over. There's like one of the contracting sort of websites is 5R, and so there's a chap from India there who then did the schematics and the PCB layout, and he didn't follow all the layout guidelines that are for the SIM 800 module. So, for example, there's certain areas where you need to keep metal out underneath. Also, some of the capacitors are not close enough to the device as well. So when we're going to do the respin, we're going to what we've decided to do is to do the schematics here in the UK, and then when we do the PCB layout, we'll make sure all of that is done properly this time. And also, we're going to go to a 4-layer board. It's only a 2-layer board, so the actual capacitor values that are on there, that they should be sufficient, but they're not. The capacitors are not really sitting in the right place on the board. They're probably a bit too far away from where they should be. Yeah. So it's not the most optimal layout on this board at the moment. Still, we managed to get it working, so it's we can actually deploy these devices pretty reliably in the river. Yeah. So it's well, if when we're working on this 900 megahertz band, what seems to happen is when the module, the SIM 800 module, tries to transmit, as soon as it tries.
Say they last about a year.
Oh, these things. Oh, the battery will just. What will happen? Oh, the failure.
Yeah.
Oh, eventually the battery will just. It can't be recharged enough capacity.
Okay.
Yeah.
So it's not a failure of electronics. It's just
Not failure.
battery.
No, it's the power. Yeah, that's right. Yeah. Or they get vandalized. Sometimes, quite often, what's been happening is, well, the other failure is just that it's environmental. They either get vandalized, or some sort of event happens, like a load of rubbish washes down the river. Could be a trolley or something like that. Someone's chucked in the river, hits one of these devices, and then smashes it up a bit.
Is it developed to replace the batteries after?
Yeah. They, I got the battery in here. It's that's usually it's actually the easiest thing to do. Once these, we've got a. If I share my screen here, we can. Let me just share this. So I'm going to let's have. If I go to device status checker, so I've got 3 devices I can check the status of. So every now and again, so all these devices they're regularly transmitting. They've each got an ID number. So my one here I've got on the table is ID 340. It did its last uploads about 4 minutes ago. John is that's John Clifford. He was the original inventor of these devices, of the Brent box. He's testing unit at home, and then we got this device here, 438, which is down by the Welsh Harp. Some of you might know the Brent Reservoir. It's a big lake. Well, it's a reservoir really, but it looks like a lake. If you've driven along the North Circular between sort of Staples and Acton, you would have seen it. So, so that came online about 9 minutes ago. That's the last time it updated something. So basically, these units that are in the field, they go online every 15 minutes. They power up, send some data, and then they go back to sleep again. Sorry?
You actually need 15 minutes? This seems like a lot.
Well, that's another open question, actually, whether we can get away with transmitting at have longer intervals. It's what the problem is with pollution. Sometimes you get like an outfall, and you want to detect it.
Yeah, but you transmit a longer period, once an hour or something like that, rather than transmitting a small amount of data every 15 minutes.
That's one of the things we're thinking. Well, at the moment, yeah, we're looking at maybe having a bit more memory on the system. So that's one of the things we're thinking about is storing more data locally and then doing an upload. Yeah, that's right. Yeah.
Regarding the data that you collect, are you monitoring the weather at the same time?
No, we don't. No, not at the moment. No.
Well, why not? Because isn't that going to have a direct impact on some of the data that you would collect?
It could do. At the moment, it's we're in the sort of early stages of this. So this is sort of what the environmental agency would like, which is basically us measuring the TDS parameter and the temperature value. And then once we get enough data, we're going to try and correlate that with different events. So there has been talk about maybe having a little camera as well. So, we could see what conditions are like.
The other one is, with all the new house building, are you finding that the builders are putting the drains into the wrong drains so that they come out on the watercourses?
Yes, that's been happening. Yeah.
Is it still happening recently? Because
Yes. Yeah.
I used to be a countryside ranger, and one of the jobs was when Time was trying to clean up the Mersey, because it was on Merseyside I was working.
Right.
All the new housing, we had 6 foot of soap suds floating down the Sankey Canal or down the Black Brook or wherever.
Right.
And I just wondered, and the houses were getting charged £3,000 to £10,000 to have all the drains redone.
Oh, really? Oh, right. Yeah.
But the builders denied all knowledge.
All right. Okay. Yeah, it's still going on. I mean, this is one of the reasons why the environmental agency wants to collect this sort of data, because if we can deploy a lot of these boxes, because they're relatively cheap to build, they should be able to get enough data together to then have to be able to sort of make up cases where who to sort of blame for the pollution. Not everything can be blamed on Thames Water, for example.
I'm not saying that.
Yeah.
What I'm saying is
Yeah, I know.
we found that weather had also had a large impact, because
Right.
after we'd had suds one day, and if it rained overnight, it had cleared the next day.
All right. Yeah.
So that's what I'm saying is it has a direct correlation, and I just wondered why you weren't doing it, because it would make a big difference to your data.
Oh, okay. Well, no, it's a good point. Yeah, I'm not really an expert on that. I'm really approaching this more from electronics. But we have got people who are sort of got expertise in biology and weather and water. So I'm going to have to ask them, I think.
Can I ask you perhaps the hardest question of all? How did you raise interest with the Environment Agency in the first place?
We have there's a chap who was one of the original sort of drivers between Clean Up the River Brent, Ben. He used to work in TV. He's very charismatic at talking to people. And, he was able to talk with the environmental agency and get them interested.
That has to be the best answer.
Yeah, we've got to. Some of the people that are in this group, they've got a lot of contacts. So, yeah, and are very good at publicising the work that we do, or Curb does. That's been quite useful. Luckily, with these units sort of working, the environmental agency have sort of kept their interest going. So that there's regular meetings with them, and then they're told how things are going, and then they decide whether or not to renew funding. And so far, things have been going okay.
Well, thanks very much for that. We have to end there.
Okay.
It was a very good, very interesting talk. Learned a lot about pollution.
Yeah.
Cool. So we'll take a quick break while I readjust the sound system and get Milo started up. So 5-minute break, everyone, and then we'll get started again.
Okay. Okay. Pleasure. Pleasure. Thank you. Thank you.
Ruben, one other question, actually.
Yeah.
Do you happen to know, I know this is well before your time, but do you happen to know when they first approached the Environment Agency, whether there was actually hardware in hand to show, or whether it was more the
yes, there was. Yeah, that original that original Brent box I showed you with all the components separately. That's what they had. Yeah.
And that presumably had seen use, and they could show some figures.
I believe so. I could do some more checking on that, but that's the impression that I got. They cobbled that. They basically breadboarded a system, and then were able to show that to the environmental agency. You find actually, because I belong to this litter picking group or conservation group of the Welsh Harp. That once you join one of these groups, you soon start meeting other groups, and it's not long before you build up all sorts of useful contacts. So it's not actually that difficult to find people, who get involved in funding. Fun, yeah, I know. It's I didn't think I'd be going from litter picking to this, to be honest. So, so
It's been a good journey.
Yeah.
That's really encouraging, actually.
Yeah.